Okay, Assalamu alaikum. Let's wait for.
Alaikum salam.
Let's wait for this in a minute, and then inshallah we'll start. طيب, Bismillahirrahmanirrahim. Now it's 10:30. So welcome to E2-1. Today is our 5th lecture and the last lecture of week 1. And in this lecture, we're going to continue talking about Kirchhoff's laws. And if you recall from the previous lecture, we actually defined Ohm's law, KVL and KCL. KCL and KVL. So we briefly introduced KVL. But if you recall for Ohm's law, we have Ohm's law relates the voltage to the current in any linear circuit. And we say that for a linear circuit, the voltage is I multiplied by R. The positive and negative depends on the positive and negative sign depends on the direction of the current with respect to the voltage. We saw that if we use Ohm's law, then we can simplify the definition of the power to I squared multiplied by R or V squared divided by R. And the one before the last thing was introducing KCL. We say that for KCL, the sum of the currents of all currents in any node is 0. This implies that the sum of the current entering must be equal to the sum of the current leaving. And if you recall, if we want to apply this equation, so we need to assign polarity for the current entering and polarity for the current leaving. So we are free to choose which polarity to assign. So normally we prefer to set a positive current for current leaving the node and a negative current for current entering the node. And we briefly introduced KVL, Kirchhoff's voltage law, and we say that Kirchhoff's voltage law states that the sum of the voltages around any closed path, or closed path is a loop. And if you recall, a loop is a point, is you start from a node, and you go back to the same node without passing through any intermediate node more than once. And KVL states that some of the voltages around any closed loop is equal to 0. Again, here we have to assign positive and negative polarity depending on whether the voltage, whether we use voltage rise or voltage drop. And in many cases, we prefer to use a voltage drop convention because it's always it's more straightforward. I mean, you didn't need to do any conversion. Again, if you use the other convention, you should end up with the same results. So let's take an exercise here and let's see what we have. So we have a lot of loops. Not a single one, and we're interested in four of those. We're interested in applying KVL in 4 of those. So I need to look for someone to participate. Someone is relatively new, and let me double check the names. They are all the same suspects. Okay. Muhammad. Let's start with path A.
Loop, I guess it's gonna be V1.
Okay, before we start, Muhammad.
Yeah.
So let me just state this. So we're going to use the positive for voltage drop. This means that if you are reaching the voltage from the positive side, you will assign positive. If you reach it from the negative side, you assign negative. Now go ahead, Mohammed.
Sorry, so the first one is gonna be minus V1
Yes.
plus V2
Yes.
plus V4
Yes.
minus VB
Yes.
minus V3 equal 0.
Equals to 0. Exactly. Excellent. So the second one was for path B with Hadi. He was Hadi.
Okay.
He was Hadi.
Minus VA.
Minus VA. Yes. So you start
Plus V3
yes. Plus V3
plus V5
plus V5
equal to 0.
equal to 0. Excellent. So path C. طيب زياد for C and Adnan for D. Okay.
So they're all, I think, are minus except for VB.
No, just say it.
Okay, CV is minus CV.
CV
VC, sorry.
minus VC.
And minus V6.
Hmm.
And minus V5. And plus VB.
Okay.
And minus V4 equal to 0.
Adnan?
Minus VA.
Just hold on a second, Adnan. Okay. Minus VA.
Minus V1.
Minus V1.
Plus V2.
Plus V2.
Minus VC.
Minus VC.
Plus V7.
Plus V7.
Minus VD.
Minus VD.
Equal to 0.
Equals to 0. Excellent. Okay.
الدكتور
Yes.
ممكن معلش سؤال بسيط.
Yes.
دكتور لو افترضنا ان ما فيه لوب، ما في اي لوب وانا اللي برسم اللوب، ارسمهم كلهم باتجاه واحد؟
من اللي يسأل الآن؟
احمد النافع.
طيب. Your question is if it doesn't show you which loop to go through, or can you repeat your question?
Do we have to draw the direction of the loops?
No.
The same for all?
I know. No, as long as your summation is equal to 0, it should be fine.
Yeah, but I mean, for example, the direction of
you can have clockwise, for example, you can move around loop A in clockwise direction and loop B in counterclockwise direction.
Okay, thanks.
Okay, good. Abdulaziz, question? Okay. دقيقة الشباب خلوا بتهاوشن.
Yes, doctor. Can you go back to the loop?
لحظة.
معلش. Yes, Aziz?
Yes, doctor.
Yes, question?
In the battery, from the negative sign to the positive sign, it's from the lower potential to the higher potential.
Yes.
So why do we put minus in the voltage?
Because we are moving in the voltage drop. So we assume positive if we are in the with the voltage drop, meaning that if we are moving from the high potential to the low potential.
I didn't understand this point. Can you explain?
So if we are moving from, for example, here, let's take this one. So we are setting the polarity here to be positive and polarity here to be negative. صح? صح?
Yes. Yes.
Okay.
Yes.
Okay. So if we are moving from the positive to the negative, it means that we're moving from the high potential to the low potential.
Yes.
So we're stating if we're going this way, we're going to assign positive. If we're going the other way around, if we're moving from the low potential to the high potential, means we are going to the left, then we assign negative.
Okay.
Very good. Ziad?
Why didn't the exercise include the last loop?
Just for some solution. Those are some examples, not all of them. The list is not comprehensive.
Okay.
Okay, very good. So now let's go ahead and solve some exercises on KVL and KCL. And let's start with, so the previous exercises were on KVL and KCL. We were attempting to solve, or we were attempting to just list the equations. Now, all what we want, or now we want to actually solve the circuit, which means that we need to find the voltage and the current. Let's start with this equation, or with this example. We have a circuit with two sources, and we are asked to find I naught here. And let's see how to find I naught. Let me start with okay. Ibrahim.
We can start by taking the loop in the left.
Okay, so before actually we proceed, so let's build a strategy here. So let's look into the circuit here and let's see what's going on. So we are asked to find I naught. In order to find I naught, we need to know if we are to. We have three options, or three laws. We can use either Ohm's law, KVL, and KCL. Clearly, Ohm's law is not. We cannot apply it directly here, because we do know the voltage across this resistor, so we cannot apply Ohm's law. So that means we need to use KVL or KCL, KVL and KCL. So let's start by which method do you think we should use, Ibrahim?
I think we should start with the KVL.
You can do that. You can do that. You can start with KVL, and
Or we could.
I want to start with KCL.
We could assign first a current for the 50 ohm resistor.
Yes. Okay. This is excellent. So let's assume that the current is going this way, and I'm going to call it IX. So let's first apply KCL at node. Let me call this one. The entire one is node 1. That's node 1. Yes, Ibrahim. So how to apply KCL here?
Here it will be IX equal to I naught plus 6.
Okay, so I just moved them to one side, and IX equals to I naught plus 6. So this is the first equation that I have. So I have two unknowns, so I need to look for another equation. And Abdul Karim,
I could do another node, or I could do the so I could say that can I, doctor, go to the other side?
The other
Oh.
side. The other slide.
Yes. So
Yes, go ahead.
yeah, I could do another one and said my node's gonna be the one under the 6 because there's 2 elements there. Can I do that?
You mean here? So you're gonna
Under the
use,
6, under the
So
6
you-
ampere.
you're gonna use this entire
Yes.
node.
Yes.
The thing is, like, you're gonna end up with the same equation. So you will have like a redundant number of equations. So probably the best strategy here is
Use the voltage.
yes.
Yeah, I could use the voltage.
So you need to apply KVL at this loop. At loop A. So if you apply KVL at loop A, if I say that this one is V1, this one is V2, then by applying KVL, I will end up with minus 120 plus V1 plus V2 equals to 0. So now I have 2 equations and actually 4 unknowns. So I did not simplify the problem yet. And Yasser, any suggestion to simplify this problem?
Yes, we can probably like V1 and V2 use Ohm laws, Ohm law, and then put them in term of resistor and current.
Exactly. From
So
Ohm's law.
yeah, so
V1
V1 will be 10 I node,
Exactly.
and then V2 will be 50 IX.
Exactly. Exactly. So now I can substitute. So I will have minus 120 plus 10 I naught plus 50 Ix equals to 0. And this is the modified second equation. So now I have 2 equations, 2 unknown. All what I need to do is solve. So if I substitute equation 1 into equation 2, I will end up with 1 into 2. I will end up with minus 120 plus 10 I naught plus 50 I naught plus 6 equals to 0. We see that we'll see inshallah in the future lectures that this could be simplified by directly solving in the calculator. So 60 I naught minus 20. So 60 I naught plus 180 equals to 0. So I naught will be minus 3 amperes. Ix will be 3 amperes. So now we solved. Now we found the value of I naught. It's negative, which means that the original assumption here that I naught is flowing in this direction is incorrect. So the actual direction of the current flow is actually in this direction. Any question before we proceed?
Yes, doctor. How did you choose the positive side for V1 and V2?
I set them to align with the current, so such that Ohm's law will give me a positive. So if you recall from Ohm's law, if the direction of the current this way, then V will be IR, if the direction of the current is this way, then V will be minus IR. So I chose this direction because I have freedom to choose.
So it's an assumption, right?
Yes. And we clearly saw that this assumption is incorrect. But again, that's the beauty of applying KVL and KCL is that even if you start with the incorrect assumption, you will end up with the same with the correct direction. Okay. Any other question before I proceed?
Yes, doctor.
من اللي يتكلم؟
عبد الكريم.
عبد الكريم, yes.
دكتور, عند ال 50 next to the 50 ohm resistance, can I say this is a node?
Between what?
The 50 ohm resistance, this one in the middle.
Yes, what about it?
Can I say this is a node?
No.
Yeah.
This is not a point where 2 ohm, 50 ohm is actually a circuit element.
Thank you.
Hassan?
No, I want to answer the power.
Okay. Yeah, go ahead for part 2. So you need to test our solution by verifying that the total power generated equals to the total power dissipated. So for part 2, the total power generated must be equal to, or in general, the total power generated must be equal to the total power dissipated. So for that reason, yes, can you find? Okay, let's start by this. Can you find the power by the 120 volt source?
For the 120 source?
Yes.
It will be 120 times 3.
It will be 120 times 3. Actually, Hassan, it's always good to refer to the passive sign convention here. So in this,
yeah, but it's always positive,
yes,
right?
yes, no, it's not always positive. 120 volt, this is the source. The source could be positive or negative. So 120, and remember the current is I0. I0 we found it to be, where is it? I0 we found it to be -3. So if we substitute, we'll end up with 360 watts. So this implies that this current is actually, or this source is not generating energy, it's actually absorbing energy or absorbing power. Okay, so who can help me with the 6 ampere source? I need the new name. Okay, I need the new name. Yes, Abdullah Balajnit. Abdullah. Abdullah, you're muted.
Yes, Doctor, sir. Can you show me the diagram?
Okay. So we have the 6 here. We have the 6 ampere source. So we need to find the power generated or delivered by this 6 ampere source.
The current.
Yes, just 6.
It's 6 ampere multiplied by the 120.
No, 120 is not in parallel with that, so it doesn't have to. So in order to, the 120 volt source is not in parallel with the 6 ampere. So the voltage drop across this 6 ampere source is not 120. But we can use Ohm's law to find, again here according to the passive sign convention, So we have to have a negative because the current is going from the low potential to the high potential. So it's going to be V, what did I call it? VB multiplied by 6. So now let's try to find VB. And VB is, using what we know, using the value of Ix. So VB from the value of Ix and Ohm's law, VB will be Ix multiplied by 50 here. So this is Ix. And VB will be this one. So it will be Ix multiplied by 50. So Ix multiplied by 50. And this can give me 150 volts. So the power will be what? Will be minus 150 multiplied by 6. And in this case, the value is minus 900 watts. So you can see that this source is actually the one that's generating energy. So since here we have two sources, we have a 6 ampere source and 120 volt source. So not all of them are delivering power, but one of them is actually delivering power, which is a 6 ampere source, and the other one is actually absorbing power, which is the 120 volts. So now we are left with the resistors. We have two of them. So we have the 10 ohm resistor, and the power here is what? You need someone, Muhsin?
Yes, doctor.
Yes.
Power for 10 or the 50 ohm resistor?
10.
Okay, will be I squared times 10 times the resistor.
Yes, exactly. I square, I naught square multiplied by 10. We found I naught to be negative 3. So square multiplied by 10. And this is going to give me 90 watts. So who's going to help me with the 50? So Abdullah al-Jariri.
Yes, it will be also I squared times R.
Yes.
Or times 50.
What is I square here?
It's 3.
Okay, Ix. So it's going to be 9 multiplied by 50. And this is going to be 450. So if we sum all the powers, we will get minus 900 plus 360 plus 90 plus 450 equals to 0, which means the total power generated is equal to the total power dissipated. Adnan, question?
Yes. For part 2, why did we put minus? Is it because we're moving from the lower?
Which one?
The
120 volts?
Yes.
Okay. For the 120 volts, remember, according to the passive sign convention, if the current is entering the element from the low potential, we have to have a negative sign. And the current here is I naught. And I naught is entering from the low potential here. Okay.
ايه لكن دكتور مو الاينت طلعت معنا ماينس يعني المفروض تكون بالاتجاه العكس.
Okay. In this case, you need to substitute positive here.
Okay.
Okay. Good. Very good. طيب. So let's move on to the second exercise here. And in this exercise, we're going to discuss. It's similar to an exercise that we solved before, but in this case we have slightly different circuit element. So we're given the terminal voltage and the terminal current, where they are measured in the device shown in part A. The value of the terminal voltage and terminal current are tabulated in B. Here we want to construct a circuit model for the device inside the box. So the device could contain resistors and ID sources. And let's see what kind of like elements that we need to actually construct. So probably the best way to do that, again, is to draw it. Ibrahim, you're trying to answer?
Yes.
Okay, hold on. Always looking for new participants. طيب, Ibrahim, go ahead. So
We plot it now. I in the x-axis and the voltages in the y-axis.
okay, exactly. So we have 30, 15, and 0. And we have 0, 3, and 6. So if we are to plot it, it will be something like this. And we can see here that the equation of this line is not a linear equation, so we have some sort of like a shift here. So the equation is Vt
to negative
30 minus 5 It. So if you just try to find the equation of this line, you'll see that the slope of this line is 5, negative 5 actually, and there is a shift here. The shift is by 30. So this implies that at It equals to 0, we have Vt is 30 volts. So this means we have a constant voltage independent voltage source, a constant independent voltage source. So even though the current is 0, so it's a lot like you're taking you have this structure or this circuit diagram, and you notice that It is 0 because it's an open circuit, so the current cannot flow there. But if you measure the voltage, you get a constant voltage. So this implies that you have a source here, a dependent voltage source. So therefore, we have independent voltage source.
Then, Doctor, we can say that the device is an independent voltage source and there a 5 ohm resistance.
Exactly, that's what we have. So for It is not 0, we have the voltage is also increased by a constant factor that's proportional to the voltage. And in this case, we see that there is a linear relation. There is a linear relation in the increase in the voltage. Therefore, we have we have 5 ohm resistor. So if we want to construct a circuit model for this one, this is a device that we have. And this is equivalent to, remember again, this is equivalent, not exactly the same, to 30 volts in series with the 5 ohm resistor. And this is VT. This one is IT. Yes, sir. Question?
دكتور.
Yes, yes, sir. Go ahead.
أحمد.
دقيقة ياسر. ياسر he raised this.
And I just wanted to answer the.
Okay. Sorry. أحمد.
دكتور الفولتج ما يتغير مع كل current.
The terminal voltage, but there is a constant voltage here. So the terminal voltage will change with respect to current. But there is a constant voltage, a constant factor here, which is the 30 volts here.
Okay, thanks.
Very good. So for part 2, is asking us to predict the power this device will deliver to 10 ohm resistor. Yasser?
Yes. We can first add the resistor to
the first thing is to draw the circuit.
Yes.
We have a 10 ohm resistor. So what will be the power delivered to that?
Now we need to use KVL on this loop. It is a single loop.
Exactly. So it's going to be minus 30.
Yes.
Let me just write this current as I. Minus 30 plus 5I plus 10I equals to 0. So the current is 2 amperes here. And the power will be I squared multiplied by 10, which is 40 watts. Okay, very good. Right. Okay. Okay, let me go back. Let me get back to this question later if we have time. Otherwise, I will post a solution for this. So this is just an extra exercise on applying KVL and KCL. So let's move to the second. Let's move to the last part of this chapter, because again the homework will be posted inshallah today by midnight, and it will cover chapter 1 and 2, and this is the last part of chapter 2. So I want you to you will have like 1 week to solve the homework. This is the last part of chapter 2, and so far, if you recall from the beginning of the chapter, we classified sources into 2 types: independent sources and dependent sources. And all of the problems that we solved so far, we've never encountered a dependent source. So here, let's try to analyze a circuit with a dependent source. So let's just start. Instead of like analyzing a circuit with dependent sources is exactly the same as analyzing a circuit with independent sources. The only thing is you need to account for is the fact that you need to add another equation for the independent source. Let's see what we have here. So we have voltage V0, and we are asked to find V0. And we have, in this circuit, we have 2 sources. We have a 500 volt independent voltage source and a 5 I delta dependent current source. So remember, our goal is to find the voltage V naught, which is this one. So let me walk you through the steps of solving such a problem. You will see that if you know how to solve a circuit with an independent source, then solving a circuit with a dependent source is not something that big of a difference. So let me apply Ohm's law here to find V naught in terms of the currents that I have. So applying Ohm's law, I have V naught equals to 20 I naught. So this is the first equation that I have. Now, all what I need to do is to find I naught. So in order to find I naught, I need to apply KCL here, Kirchhoff's current law. So in this node, I have I delta is entering that node, I naught is leaving that node, and Shabab, I want to solve this one just to show you the steps. And 5I delta is entering that node. So let's try to do that. Okay, so I naught will be positive because it's leaving that node. I delta will be negative because it's entering that node. And again, 5I delta will be negative because it's actually entering that node. So this implies that I naught is actually 6I delta. So now, okay, I know that I naught is 6I delta, but it's still like I don't know I delta. So in this case, I need to apply KVL at loop I. So let's apply KVL at loop I. So if I apply KVL, I'm hoping by this time you guys know how to apply KVL. So minus 500 plus, I'm gonna express everything, just a minute, in terms of I naught, because that's the current, or I delta, that's, I'm gonna express everything in terms of I delta. So if you recall that I naught is 6I delta, so in this case 5I delta plus 20 multiplied by 6I delta equals to 0, so I delta will be 4 amperes. So once I know the value of I delta, I can find the value of I naught. I naught will be 6 multiplied by I delta. Which is, in this case, is 24 amperes. And once I know the value of I naught, I can find the value of V naught, which is the thing that I've been asked to find. So V naught will be 20 multiplied by I naught, which is in this case 20 multiplied by 24. And you can see here that this one is for 80 volts. So you see the steps here. There is nothing different. There's no difference between having an independent source and dependent source. The only major difference, or the only difference here, is that you need to account for the fact that you need to add an extra equation, which is in this case If, say, for example, we have an independent current source here, then we will not need this equation. That's the only addition that we had in this analysis. But other than that, everything is exactly the same. Okay, let me just don't leave the meeting. I want to make an announcement, but after the class.
Doctor?
Yes.
Do you mean if we have a dependent source, so we should apply Ohm's law additionally?
It depends. It depends what law you need to apply. So it means that the only thing that the dependent sources usually add is the fact that you need to apply more equations. But the analysis is the same. So we have not used any new formula here. All what we used was Ohm's law, KVL, and KCL. So nothing new.
Yes. Thanks.
Okay, very good. So let's try to solve this exercise here. And in this exercise, we're given this kind of equation, or this kind of this circuit diagram, and we are asked to find I naught. So anyone wants to try? So let's find I naught. Looking for new names. Omar, Saleh.
Yes.
Can you
first to apply Ohm's law, so we can say V naught is equal to I naught times 6 times 10 to the power 3.
No, we're looking for I naught. So if we want to actually the loop that we are interested in is this loop. So again, here there's no current flowing from this direction to that direction.
Oh, okay. So we will use KVL directly, right?
Exactly, but we're missing some components here.
Which is V1, I guess.
Yes. How to find V1? So from Ohm's law, V1 can be found by applying Ohm's law in this loop. So V1 would be what? 4K multiplied by 10 milli, which is 40 volts, right?
Yes.
Okay. Now, Munir.
Yeah.
What should be the next step?
Find V1 over 2, which is 20 volt.
Okay.
Then find I naught.
Okay. By applying KVL. So let me lump all of these steps in one step. So applying KVL. So it's going to be minus 20 plus 2K multiplied by I naught plus 6K multiplied by I naught equals to 0. So it's going to be minus 20 plus 8K I naught equals to 0. So if we solve for it, we'll end up with 20. And this is going to give me 2.5 milliamperes. So this is the first part. The second part is asking us to verify the values of I naught by showing the power generated in the circuit is equal to the power absorbed in the circuit. I guess by this time we are all familiar with the way of doing that. So Ziad.
الدكتور
Yes.
الدكتور ممكن إذا ما عليك أمر تنسخ السؤال وتحطه جنب الإجابة بس عشان نشوفه أثناء الحل.
I don't have enough space.
Okay.
But the slides are available on Blackboard, so you can, if you want to download them and have them like next to the questions, they are available there. طيب okay. محسن, question?
No, I want to participate.
Oh, okay. So in this case, if we want to verify this value by showing that the power generated in the circuit is equal to the power absorbed in the circuit. So Mohsen, what will be the power generated by the 10 milliampere source?
Will be I times V.
Yes, which is in this case, again, there will be a negative sign here.
Yes, the minus sign.
Minus 10 milli multiplied by 40, which is minus 0.4 watts. Now let's see what will be the power dissipated in the 4 kilo ohm resistor. Ziad?
It will be I square R.
Which is I square in this case. Let me just write directly. Clearly, these two circuits or these two loops are independent. Since here the power generated in this loop by the 10 milliampere source is being completely dissipated by the 4 kilo ohm resistor. So now let's see the power generated by the 20 volts source or negative 20 volt source. إبراهيم. أو دقيقة إبراهيم. وليد باقي.
Yes, Doctor. IV.
IV. What is?
Yes, I know. I know this is 2.5 milliampere.
Okay.
Multiplied by minus 20.
Multiplied by minus 20. In this case. Which is minus 0.05.
Doctor?
Yes.
I want to interrupt, but I think it is 4 milliwatt for the power because squared milli.
4 milliwatts?
No. The answer for the one before.
You mean 0.04, right?
Yeah. Shouldn't it be 4 milliwatt?
I don't know. Okay, 40 multiplied by 10.
No, صح.
No, they have to be the same. The one on the top and the one on the bottom, they have to be the same.
Okay.
Okay, because 4K is 4 times 10 to the power 3. So power of the 2 kilo ohm resistor is Ibrahim.
I naught square times 2 kilo ohm. Then it will be 2.5 times 10.
0.0125. Yasser, 6 kilo ohm.
Yeah, it will be I squared times R, which is 2.5 milli squared times 6K.
Okay. 0.0375 watts. So if you add this one with that one, you should get the same value as that one. Okay, very good. So we see here that the application, whether we have dependent source or independent source, this should not matter. The only difference is that we need to add more equation. Ibrahim, yes, question? Omar?
Yes, doctor. Why did we put minus 20 volts, not 20?
I would do it this way. Yes, 20, yes. Okay. I will choose negative.
Yeah, I mean, but you named it minus 20 volts.
Oh, this one? Yeah, by accident.
Oh, okay. Thank you.
Salah?
Yes, doctor. Are the solutions uploaded in Blackboard?
Yes, they're always uploaded after the class, not before the class.
Okay, thank you.
Okay, so let's go back to the question that we skipped. So in this part, again, this is for independent sources. We have a 16 ohm resistor here, which is that one. And we are given that the voltage here across it is 80 volts, positive at the upper terminal. The question that we are asked to find is we want to find the power dissipated in each resistor, which means that we need to either find the voltage or the current in each resistor. So this is kind of like a very lengthy, very exhaustive problem. But the key element here, if you want to solve it, and I'm not going to spend so much time on it, because I'm going to post a solution for it. So the key element here is actually to know is to simplify the circuit by redrawing it. So if you redraw the circuit, it will be something like this. So I have 125 voltage source. Then I have 7 ohm resistor, 15 ohm resistor. I have 5 ohm resistor here, and I have 16 ohm resistor here, and I have 30 ohm resistor here, and finally I have connecting the entire circuit. So this is exactly the same as this circuit. So those are identical. The only difference here is that this one is more compact. So if you want to build this circuit actually physically, you will do it this way. But if you want to analyze it, it will be always easier to redraw the circuit in this manner. This one is 80 volts, and the general steps is you start with something that you start with the equation that gives you one unknown. And in this case is applying KVL around this big loop. So if you apply KVL here, we'll get minus 125 plus the voltage here, let me call it V15, plus 80, which was given, equals to 0. From that, you can find V15. Then the next step, now you know V15, this one, you know 80, you can find the current here. You can find the current in both, the current passing through both resistors, 15 and 16, by applying Ohm's law. So you know exactly how to find the current in these two resistors, and you have the value, you have access to these values. So now you can use what you know to find the current passing through the 5 ohm resistor by applying KCL. Then you keep repeating the same procedure until you reach a point where you have either the current or the voltage in every part of the circuit. Once you know that, you can determine the power by applying either I squared multiplied by R or V squared divided by R. So I'll post the solution for this one. And okay, let me stop recording. And I want you to be